My name's Matt George. I'm a Python developer here in town. Binary Dud is my Twitter account and GitHub account. That's where you can find me if you want to know more about the stuff that I do. But my talk is on SMTP and message queues and how they're related, and how the design of SMTP is really still pretty good in terms of if you look at the way that message queues are designed today. So first, what are message queues? It's really about asynchronous communication. They facilitate passing messages, usually in order from end senders to end receivers. They can facilitate inter-process communication. And one of the big advantages is the nodes don't have to be connected at the same time. So someone can send a message to a queue, and the receiver doesn't have to be listening at that time. That's a particular. There are use cases where that's not the circumstance, but for what I'm going to be talking about, that's generally the case, where you're adding a message, you're sending out a message, and then a receiver is getting that message at a later time, but not necessarily connected. And generally, the senders and receivers can be spatially independent. They don't need to be near each other. They can be, but they don't have to be. And in the case of what most people use message queues for, they can be anywhere from across networks to the same machine to different machines on the same network. Modern implementations of message queues, what most people think of message queues, include stuff like ActiveMQ, RabbitMQ, SoniCMQ. Those are just some of the standard bigger ones that are used today. So who are they for? I'm going to look at two common use cases for message queues, but there's a lot of different uses. So event notifications. This is one that's pretty useful, especially in like a web application framework, or any case where you want to have an event that is listened to by multiple receivers. So one sender generally sends out a message, lets the subscriber let subscribers know that an event has occurred. The sender doesn't need to know who's listening, and can send out one message, and many people can receive that message. The receivers can often subscribe to one or more event channels. Another use case that's really has been used a lot recently is background jobs. So especially in the web world, you don't want to do long-running work in a web process. So a lot of times what you do is you pass a message to a message queue, and then your worker processes sit in the background listening on that message queue and get jobs and then process those jobs. One of the things that we do kind of that work for this use case is we process a lot of data where I work. For people, they kick off jobs to get a query from a certain data set, and it's too big to run in a web process, and so we background that job, and we use a message queue to send the information to the background jobs to say, this is the database I want you to connect to, this is the query I want you to run, etc. And then we will use the same message queue to send data back to the web process to let the person know that their job is ready to view. Okay, so what is SMTP? How does that fit into this talk about message queues? SMTP stands for Simple Mail Transfer Protocol. It was basically defined in 1982 under RFC 821. It's been extended a couple times. I think the newest RFC is 5321. And a lot of the extensions have to do with security and enhancements. It came out of kind of two competing, or not necessarily competing, but complementary standards. One was called the Mailbox Protocol. The other was called Send Message, except all the vowels were taken out of that. Basically came out of ARPANET. And instead of having competing programs, they decided to build a protocol to handle the communication between people, machines, etc. It's text-based, and it's basically how we all send mail. So how does it work? What's the SMTP process model look like? This is basically one SMTP message. Each command is sent to the server one at a time. It waits for a reply. The server's reply can be positive or negative. Positive is 200 codes just saying, hey, this was accepted. Negative replies can be permanent or transient. If you're familiar with HTTP reply codes, it's very similar, 400 and 500 series codes. everything after the data command is optional. And I didn't include it in here, but actually after the data command, you have to include a period on a single line. That's how you terminate the data command in an SMTP conversation. So you can see that SMTP is pretty simple in what it sends, what it's available. I don't know if I said it, but it is text-based, and I'll get into that later. So here's the more on the process model, and I'll define each of these terms. So MUA is mail user agent. A lot of people, this is your email client. It's what connects to a server to actually start the conversation. And the mail user agent connects to a MTA or mail transfer agent. That mail transfer agent basically handles taking that message and then delivering it to where it needs to go. And the mail transfer agent is typically talking to other mail transfer agents. And that can be many mail transfer agents within the same network. But once it hits the boundary, once it's gotten to the point where that the boundary mail transfer agent needs to communicate and figure out where the, sorry, I lost my train of thought. The mail transfer agent at the boundary has to locate the target host, and it uses DNS to do that. It queries the MX records in DNS to figure out for a particular domain where the server is and what server to connect to. Within the MX records, you can actually have many MX records, and you can prioritize your MX records to determine which server you want to receive mail on. Once that happens, you can, I don't show it in this kind of quick little graph, but the MTA will continue to talk to other MTAs until finally the system decides what the mail delivery agent is. That's the MDA. That's what actually stores the message into what's called the mailbox. A lot of times MTAs and MDAs will be basically the same process. And then mail clients will connect to the mail delivery agent to get the mail onto your local machine. That's kind of outside of SMTP. That's generally handled through IMAP or POP. And it's not really relevant to the delivery of messages. Like I said, it's a text-based protocol. One connection can include 0 or more transactions. So you can send a lot of data over one connection. So what does that mean for message queues? Well, message queues basically do the same thing. You put a message in, and it gets to an endpoint, and someone takes it off the queue. SMTP has been around, like I said, since 1982. Some implementations even before that. And yet it still is very fault tolerant. There's a lot of data that gets sent via SMTP. If you think of every single person in this room probably uses SMTP in order to send mail. And that's a significant amount of traffic on the internet. So we're all sending a lot of data in a very asynchronous manner every day using a protocol that was designed back in the 80s. And actually designed probably before then. That's when the RFC was actually started. SMTP defines the mail transport, not the content. So the content, and kind of what that means is that the protocol defines how to send stuff. The message is actually, the message that's sent is up to the implementers. The message format was defined in RFC 822. But that's not really related to SMTP. And like I said, each implementation of an SMTP server kind of determines what gets sent in a message in the data part that I showed earlier. Because of the underlying use of DNS, it's a very fault-tolerant system. You can, the way most of the implementations work is they'll actually, if they can't connect to a host, they actually leave the message in their queue and try for a significant amount of time. One of the other things that's available in SMTP that a lot of message queues kind of are optional is there's SMTP allows for transfer back to the originator messages about what's going on. There's also a lot of stuff in SMTP in terms of the headers that are sent that allow you to track what happened to a message. So talked a little bit about SMTP and how it's an interesting queuing system. What are some of the issues with it? What are some of the things that are starting to be done in a different way with message queues that SMTP doesn't do? SMTP is really chatty. For a message format, it sends a lot of data, and it's all text. That takes up a decent amount of space when you're sending something over the wire. A lot of the newer messaging systems use binary protocols and have their own very specific protocol. That's one of the things, like AMQP is a pretty bigger, it's a bigger messaging form or messaging protocol that's in some ways very similar to SMTP. It's a protocol that servers implement, which means that different servers can talk to each other. But they're using more of a smaller format to have smaller messages when you send data over the wire. Some of the more recent message protocols are much slimmer. And you're starting to see some use cases where SMTP isn't as up-to-date as some of the current protocols in terms of some of the stuff that you can do that the protocol doesn't necessarily define. Like I said, it's up to the implementers. So we all know about mailing lists and that kind of stuff, but that's not really part of SMTP. That's what people have implemented on top of it. The protocol itself is kind of dumb when it comes to what you can do with it, whereas some of the newer messaging protocols are much smarter about what you can do with a message, how you track messaging and stuff like that. But as a protocol and as a delivery format, it's actually stood up pretty well over the test of time.